Hello. Hello. Good evening, everyone. Hope I am audible. So, welcome to today's tutorial session of week 7 for the course Calculus of One Real Variable. Okay, this is Rahuldev Ghorai from ISA Tiruvananthapuram. Your course instructor is Professor Joydeep Dutta. So, for this week, what are the things has been covered are this. So, first is like you have definite integrals, which we have already discussed a little bit, so I'll not go into details today. But I will be mostly talking about today numerical integration, which is one of the important topic, and sequences. So numerical integration, why I'm not doing definite integral, mostly we have done it the last lecture, because this definite integral was in the two divided into two parts, first part and second part, and yeah, it's mostly we have done areas and all little bit, all right. And so we'll start directly with numerical integration, right? So in the numerical integration, what are the only two method has been done, right? Like trapezoidal rule and Simpson rule, right? So what are these? These are to approximate integration. Some integration might be difficult, but you can approximate those using this trapezoidal rule or Simpson 1/3, that Simpson rule, right? So all integrations are like, you cannot do like exact integration, right? So you need, that's why this type of uh, rules, approximation rule, to somehow approximate that integration value. So okay, so I'll start with let's say, right? So this is okay. First question 1. Let's say you have given a function whose values are I mean, yeah, f of 0 is 2, f of 2 is let's say 4, and f of 4 is 0, and you need to find the integration value fx using trapezoidal rule in the domain 0 to 4, right? So how to do that? So what we do in the trapezoidal rule using mainly the function here looks like this, right? So it start with 2 and it goes and it is 0 here, at 4 it is 0, right? Some type of curve. It might be, it can be like this or it may not be like this also. It can be also like only some lines, right? 0 to 4 we only know value, so 0 to some 2 and some 4, it can be also like that, okay? But whatever is that if we using trapezoidal rule mainly, we will try to find what is the value. So it's using this 0 to 4, and if you use also in the questions, let the del x is equal to 2. Del x mean the interval uh, has been divided into this, so 4 minus 0 over uh, n, that is del x, and del x is equal to means n will be 2 points you have to take, right? So yeah, number of intervals is 2, n equal to 2, then the del x will be 2. So number of intervals 0 to 2 and 2 to 4, right? Two intervals if you do, so then using trapezoidal rule, if you del x over 2 f of first point plus f of x naught plus this del x, that 2 times, and plus f of x naught plus 2 del x. Sometimes they call it also del x by 2 f of x naught plus 2 times f of x1 plus f of x2. They are nothing but same, and here f of x naught is 0, it's initial value 0, x naught 0, so that will be equal to del x over 2 f of 0 plus what is f of x1, which is x naught plus del x, which is 2, so that will be f2, so that is 4, means 2 times f of x, f of 2 plus f of 4. Now you know all the values, del x is 2, so 2 over 2, f of 0 is 0, right? F of 0 is 0 plus, no sorry, f of 0 is not 0, f of 0 is 2 plus, sorry, f of 0 is 2 plus 2 times 4, right? 2 times 4, f of 2 is 4 plus 0, so that is 10. This will be your answer, right? It's approximate answer, of course. So yeah, that is approximate answer, but yeah, that is the thing. Okay, so we'll move to the question 2, second question. Question number 2. So we, let's say E is the error. Error in the trapezoidal rule. So What is the meaning of that? So if you have a to b fx dx, if you want to approximate, the approximate value is t, or more precisely it is depends on n number of step, you say number of intervals, you ask that norm of that mainly is equal to e, which you know is less than equal to, let's say, b minus 1 by go over 12 n square, right? So whenever k is f prime double prime x is less than equal to k, let's say, for all x belongs to ab, correct? So then that you know, let's say. So then question is find a value for n, means number of intervals, for which means how many partition you need to do in that interval a to b, for which the trapezoidal approximation to this integration 1 to 3 1 by x dx is equal to ln 3 has an error. What is that? That error e is less than equal to 10 to the power minus 4 over 3. So the question is, I hope it is fully clear to you that if you want to approximate this integration, which you know the exact value, which is ln of 3, how many number of intervals we need? We know more. We take intervals or trapezoidal rule or whatever this Simpson rule. This approximation will be much more precise, much more uh, errorless. So when n equal to like whatever the value of n, for which the error will be 10 to the power minus 4. This is the question is asked. Okay. So in this case, interval is 3 to 1 to 3, right? That's the interval. And your function is fx is 1 by x. As we know this, we need some f double prime x. F prime x is minus 1 over x square, and f double prime x is equal to 2 by 3x cube. Sorry, 2 by x cube, and that is decreasing, right, on the interval 1 to 2. I mean, sorry, 1 to 3, right? So in the interval f prime x on to 2 to 3, yeah, whatever is that, that will be decreasing, right? So it will give you f prime x, f double prime x is less than equal to f prime 1, right? Because it's decreasing, and that is nothing but equal to sorry, not f prime, f double prime, of course, f double prime, that is f double prime is equal to 2. So you can simply take k is equal to 2. We need a k also, right, for this error estimate. So then your e will be less than equal to k times, means 2 times b minus a is 3 minus 1 whole cube over 12n square, right? So to find a value for n for which e will be less than equal to 10 to the power minus 3 over 4, what you can simply take 3 minus 1 over whole cube over 12n square has to be less than equal to 10 to the power minus 3, sorry, 10 is 4 over 3. If this happens, then we can say that this error is less than equal to 3, because this and this together will implies e less than equal to 10 to the power minus 4 over 3, right? A less than b, b less than c, so a less than c, right? So now what will happen then? So that implies 2 times 2 cube is 8. 2 times 8 over 12n square is less than equal to 10 to the minus 4 over 3. That implies 4 over n square has to be less than equal to 10 to the power minus 4, or n square greater than equal to 4 times 10 to the power 4. That implies n greater than equal to 2 times 10 square is equal to 100. So you need at least 100 intervals to make this of error, approximation error 10 to the minus 3, 10 to the minus 4 over 3. N equal to 100 means delta x has to be 3 minus 1 over 100, that's by 0.02, right? So you have first 1, and then you have 1.02, 1.04, 1.06, and it will keep on going up to up to 3. So the intervals 1 to 1.02, 1.02 to 1.04, like that. These will be 100 intervals, and what you need, so mainly you have to take 100 intervals to make this error 10 to the power minus 4. Okay, so what you can do, you can check with different value, different instead of n equal to 100, or del x equal to 1, del x equal to 2, or del x equal to 0.1, you can see for this one approximation error will be less. This will be error will be much more like bigger. So that you can, for this trapezoidal rule, you can just cross check. So I'll do this type of thing for Simpson rule anyway. So yeah, so trapezoidal rule, let's say one more thing you can do, like another question. Let's say you have given, so question 3, so data are like given like this: x, fx, 0 then 1, 1 then 1, 2 then 2, 3 then 3, but not 4 at 4 or 5. Then find the integration fx from 0 to 4, right? Dx using trapezoidal rule. trapezoidal rule. Okay, it's not trap, it's a trapezoidal rule, shortcut written. Okay, so trapezoidal rule, then what will happen? So also, yeah, del x of course has to be 1, otherwise you don't know for other values. Del x is equal to 1 means first is 0, and then 0 plus 1, 0 plus 1 plus 1, 0 plus 1 plus 1, and like that it will be 4 at the end, right? So here also the del x is over 2 trapezoidal rule. What it says, trapezoidal rule says that it has to be f0 plus 2 times f1. So plus is not just f2, right? It has to be 2 times f2 plus, or again 2 times f3, whatever is there, and at the end it will be f4. You have to remember like this, and that will be del x over 2. What is f0? That is 2 plus 2, means f1 is 2 times 1, 2 plus 4, 2 times 2 plus 2 times 3 plus 6 plus f4 is 5. So, and what is del x? You assume del x is 1, right? 1 by 2 times 4 plus 4, 8 plus 6, 14, 5, 19. So that is equal to 9.5. That will be the answer. So if you know a few points, like at 0 the function value is 1, at 1 the function value is 1, at 2 the function value is 2, at 3 the function value is 3, and at 4 the function value is 5, then you can use the trapezoidal rule to find out the integration value, or the like approximate, of course, approximate integration value of the function using this trapezoidal rule, and that will be the area will be 9.5. Right. So I end for trapezoidal rule. Now I go to composite numerical integration. That is, Simpson rule. So Simpson 1/3 rule. Simpson mainly. Simpson 1/3 rule. That mainly you have, let's say, 0 to 4 e to the power x, sorry, no, 0 to a to b, right? A to b fx dx, mainly it divides into 3 interval, sorry, 2 interval, and it gives 2 by 3 f a plus 4 f of a plus h plus f of a plus 2 del x. Sorry, I mean h means del x, of course, plus del x. So which will be a plus 2 del x will be b mainly, that is nothing but b. So let's say using Simpson 1/3 rule, we want to find 0 to 4 e to the power x dx. What is the exact value of this? This will be e to the power 4 minus e to the power 0. If you calculate it, the exact answer will be 53.59815. But when you use, sorry, this is h over 3, not 2 over 3, h over del x over 3. Okay, so in this case, if you use del x equal to 2, then you can have 0 to 4 as 2 intervals, right? And then you can use, this is exact value, and in this case del x will be 2, so it will be 2 by 3 using Simpson Simpson rule. 2 by 3 e to the power 0 plus 4 times e to the power 2 plus e to the power 4. That if you calculate, you will get 56.79, sorry, 76958. So error will be minus 3.17143, right? Too large. So error is minus 3 points, right? So I mean very large. So errors has to be like at least 1 over 10, 1 over 100. I mean that more error, that is okay. It's much better, but yeah, it's minus 3 you need, right? That error. Because what is the thing here we have used? Del x is equal to 1 we have used. We had used. Now, sorry, not 1, 2, right? Now, let's take del x is equal to 1. But when del x equal to 1, so first point is you had 0 and then 1, and you can go up to 2, and then you can have these two intervals, and then you have 2 to 3 and then 4, that can have two integrals. Now what I'm saying, 0 to 4 I want to do fx dx, right? That's what you can write as 0 to 2 fx dx plus 2 to 4 fx dx. We can do these two and then we can use this Simpson rule, because now del x is equal to 1. When del x equal to 1, the interval, in the interval 0 to 4 fx dx, you cannot use directly. Otherwise, you have to remember the formula. Otherwise, you can remember. Otherwise, like if you can remember, then it is okay. Otherwise, always we know for two interval. If del x is equal to 2, then we know, right? So when you have 0 to 2, for that del x will be 2, but actual del x is actually 1. Yeah, I mean, sorry, del x is equal to 1, but number n is equal to 2. For a number n equal to 2, we remember, right? So that's why it's 0 to 2 fx dx. That will be del x over 3 means 1 over 3, using Simpson rule, of course, 1 over 3 f0. What is f0? F0 is e to the power 0 plus 4 e to the power 1, because the x is 1, plus e to the power 2, right? Because in this case n equal to 2, we use that same formula, plus 1 over 3. Similarly, it will be e to the power 2. It will start with 2 to 4, right? 2 plus 4 e3 plus e to the power 4. The whole thing together you can calculate and you can get 53.86385. And you know the error now is equal to this 53.86385 minus, what was the exact value? This 53.59, something like this, and then that is minus 0. I mean, this will be negative power, so 0.26 minus or plus. If you take absolute value, that will be 2657. See, our error was initially it is minus 3.17143. So it became it became now 0.26, much less, right? So you can, at home, you can try with del x is equal to, sorry, del x equal to, del x is equal to half. So then what we need to do, the intervals will, number of intervals now will increase, and what we have, 0, half, then 1. With that one interval, sorry, with that we have a interval 0 to 1, and then 1, 1 half, and 2, that is one interval, like that, 2, 2 half, 3, that is one interval, and I think we need to go up to 4, right? 3, 3 half, and 4, that is another interval, right? So whatever the integration value we have, integration 0 to 4, right, we have fx dx, that you can write 0 to 1, 1 to 2, 2 to 3, and 3 to 4, plus plus plus, sorry, f plus f, f. And now you can use, you know how to use 0 to 1, in 0 to 1 f, the Simpson rule, right? First one I will say maybe del x is half, half over 3, f0 is e to the power 0 plus f half, e to the power half, it will be, right? 4 e to the power half, sorry, plus e to the power 1, that is e. And similarly you do all this business, and you can see, you will see, you do it at home by yourself, and you will see it will be 61622. So now error becomes 0.01807. See, with del x, I'll do del x is equal to 2, error was 3.17. 3.17 with del x is equal to half, sorry, this is equal to 1, error equal to 0.26. 0.26. I'm writing just only two terms. Del x equal to half, error become much lesser. So more you take del x, more you take del x closer to 0, the error will converge to 0 also. Del x tends to 0, error will also converge to 0. You will get better approximation. And error converges to 0 means you are getting more closer to the exact value. That's the meaning. So that's how the, like, all the Simpson rule or your trapezoidal rule, you try for also trapezoidal rule, you will see the same thing happening, where you will see that this as del x tends to 0, trapezoidal rule also gives much better result. Yeah, you can do error analysis also. That's in that sense. Yeah, I think that's all for these things. So you need to only need to remember the formula for when n is equal to 2, number of intervals are 2. So then you have this for trapezoidal rule, a to b fx dx. Of course, I am always telling for n is equal to 2, or del x, when n equal to 2, del x will be b minus a over 2. That will be corresponding, del x will be b minus a over 2. Yeah, and then fx will be, in that case, will be del x over 2 fa plus f of a plus del x, sorry, this is 2 times plus f of b, which is a plus 2 del x. And Simpson, right? That's what we have done, right? This is fx trapezoid del x. Yes. It will be Simpson 1/3. It says it will approximate. So all are approximation. But as I said, according to trapezoidal, that's why we can write as equality also. So del x over 3 fa plus 4fa plus del x plus fp. That's all. If you remember these two, you can do it for more and more things, right? For it's for n equal to 2, we can do it for, if n is equal to n is strictly better than 2, you make, let's say n is yeah, depending on the n. So if you have n is equal to 3, then you make the intervals into the sub intervals, summation of sub intervals, so that it becomes n equal to, you can do it for n equal to 2. Yeah, so hopefully it's understood. Yeah, we are like end of first part of the tutorial session. Okay, so we'll move to the now sequences, which is one of the most important thing, and here it comes real analysis. Sequences, which are the functions from set of natural numbers to real numbers, mainly sequence of, then we say sequence of real numbers. Sequence of complex number, if you say, then it will be real from natural numbers to complex number set. Sequence of some other valued function, if it's a form n to f, from n to, you can write to any x also. That will be that x valued function, x valued sequence. So mostly will be, so in this course it will be R, set of real numbers. So real valued sequence. And when we say in this course sequence, mean it is a real valued sequence. So f at 1 will be some, let's say a1, f at 2 is a2, and like that f of at n will be an, and it will keep on going. This sequence, instead of writing function x f, you can think it's like f an, which goes from n to r, you can think like that. And we can write like n belongs to natural number. That will implies that this is a sequence which is, it's inherently, it is a function from n to r. Okay, so mostly we'll be saying an or xn as sequences. So yeah, I mean, so sequence is, you can, it can be xn. If I say xn is equal to 1 for all n, then it's a constant sequence, or some other number, it's a constant. Example of constant sequence. Constant sequence. So it's a, this is also trivially a sequence. It can be 0, it can be 1, 2 always. Xn is equal to n, that is also sequence for all n. Let's say xn is equal to 1. So number is 1, then 2, xn is equal to n gives natural number to natural number mainly. xn is equal to 2n, that will be 2, 4, 6 even numbers like that, right? These are all our sequences. Sequence means you have a map from N to R. As I said, real value sequence of course, but yeah, that is a sequence for us. Okay, so these are the example of sequence. Let's say like you have a 1 by n, so sequence like let's say 1, 1 by 2, 1 by 3, 1 by 4, it keep on going, and you hopefully you can see it approaches to 0 mostly. It approaches to 0. So yeah, you have sequences, you have limit definition, sequence, you have xn. What's the limit of xn? All of these things are done hopefully. Yeah, not hopefully, it's done, I have seen. So what we'll do, some examples to verify whether one can really do the find out the one can really verify the sequence if sequence is converging to some point. Let's say for this 1 by n sequence, you can apparently you can say that it converges to 0, right? It's approaching to 0. But how can you say something like this? 1 minus n 0 less than epsilon for all n belongs to some k. Find k, and that is the meaning of limit, right? If a sequence xn converging to L, the tail ender of the sequence, or the after certain, that can be 1 crore or 1 billion or 1 like 1 million, whatever. Sorry, more than 1 billion. At after certain stage, certain step, they should be very very closer. That is the like as much closer as we want. Now if you have for every epsilon, whatever small, like however small that epsilon is, you will find a finite number k, which depends on of course epsilon, but after that number, this will be the limit, and the sequences, all the points will be that much smaller. So how do you show that this 1 by n is less than epsilon? See, this one is very easy. What you do, n, if you take greater than 1 by epsilon, where k is, let's say 1 by epsilon plus 1, right? Then what happens? See, 1 over epsilon is the greatest positive integer less than epsilon. So what you can say that n greater than epsilon with 1 by epsilon plus 1, that you can write, right? Okay. Okay, let me think of doing in a better way. Okay. If n is less than epsilon, then 1 by n is less than epsilon. Yeah, if we consider if n is greater than epsilon and k is equal to this, then n greater than equal to k implies n greater than equal to 1 over epsilon plus 1, and that is greater than equal to 1 over epsilon.
and that implies 1 by n less than epsilon, and that implies 1 by n minus 0 is less than epsilon. So whenever n is greater than equal to k, 1 by n minus 0 less than epsilon. So let's say epsilon is equal to in this case I'll assume okay, no, yes, 2 by not 2 by, yeah, 1 by 2 times 10, let's say, right? Let's say epsilon is like this. Then what will be your k? Then from here what you get, k will be 1 by epsilon means 2 times 100. No, sorry, not 2 times. Let's assume, see, for simple examples it will be easy, but what about this type of example? So 2 by 10, epsilon is equal to, no, so still it will be no problem. Okay, something like 11, 2 times 11. Okay, yeah, let's say 2 times 11, smaller number, and for if 1 by n sequence is converging to 0, for this epsilon you will find a k, after that it will be closer to that. So k is equal to then 1 over, so 11 over 2, so plus 1. So this is the greatest positive integer less than equal to this number. So that implies this is what will be. So let's first write 5.5, right? Plus 1. Why I was writing plus 1, you will understand then. So this will be 5 plus 1 is equal to 6. So when, then what you can say, 1 by n minus zeros is less than 2 by 11 for all n greater than equal to 6. That is the k value, right? It's not for all n greater than 5. Not for n greater, not n greater than equal to 5. It will not valid. So that's why 1 is plus 1 was needed. So that you can see, because if n is equal to 5, 1 by 5 has to be less than 2 by 11, and that implies 11 less than 10, which is not valid. So it has to be, that's why that plus 1 I was taking always due to that thing. You will that also you can understand, I guess. So for every epsilon, like this you can find, see, epsilon is, if you 1 by 100, then it will be easier. So that's why I was taking 2 over 11 or some such thing. So that will be then 100. In that case you don't need to take any plus 1 maybe, right? Yeah, that you don't need to take plus 1. 100 plus 1, that is 101. Even with 100 also it will work. But yeah, here is 101. See, if n is greater than equal to k it holds, then it will hold for n greater than equal to also k plus 1. So that is the thing. So we'll do some more important limits and then we'll stop the sequences. So you hopefully you know about the bounded sequence. So let's say 1 by n sequence is bounded, right? 1 by n is bounded sequence. Bounded sequence means sequence xn, if is less than m for all n, then it's bounded. M should not be depending on n, of course. So 1 by n sequence is the bounded sequence. Minus 1 to the power n, so bounded sequence, right? How does bounded 1 minus 1 to the sequence logarithm is, first will be minus 1, then plus 1. So minus 1, then plus 1, and keep going. So one you can see it's a bounded sequence, but it's not converging, right? So oscillating and keep on going. And when you have bounded sequence, it may or may not be convergent. So bounded does not imply convergent, but convergent imply bounded. This you can check it. Also, if your sequence have a limit, a sequence have can have at most one limit. That also is very easy to verify, right? So you take, let's say, xn, you have, let's say, xn converts to two limits, let's say L1 and L2. Then what you have, according to definition, xn minus L1 is less than epsilon, and xn minus L2 less than epsilon. But for and this epsilon, for this epsilon, this for all n greater than equal to, let's say, k1 and n greater than equal to k2. So if you take k as maximum of k1 and k2, max of k1 and k2, can you see this, that xn minus L1 less than epsilon for all n greater than equal to k. Also xn minus L1, it will hold for all n greater than equal to k, right? This will hold, and that implies, because n greater than equal to k1 implies for all n greater than equal to k, it holds, means n greater than equal to is a maximum of k1 and k2. That will also hold. That implies xn. So now I'll write is like modulus. Okay, I'll just write mod of L1 minus L2. That will be, you can write as xn minus L2 minus xn plus L1, right? That you can write like this. That is equal to xn minus L2 plus, sorry, minus xn minus L1. These two mod is that nothing but less than equal to xn minus L2 plus xn minus L1. That is nothing but greater than equal to 2 epsilon. So L1 and L2 are two real numbers that is less than equal to epsilon. For all epsilon greater than 0, epsilon you take 1 by 2 times 10 to the power 10, epsilon equal to 1 by 10 to the power 1000, keep on going. I mean, so we have also seen a minus b less than epsilon for all epsilon greater than 0 implies a equal to b. Here also instead 2 epsilon you have 2 epsilon, but things are same, right? So that it does not matter whether 2 epsilon or 10 epsilon or 20 epsilon, but it's like when 20 epsilon you have the epsilon prime, epsilon equal to epsilon prime by 20 you can make, and that epsilon prime is any number which is greater than 0, right? So it does not matter 2 epsilon, 3 epsilon. So, but two number whose difference is less than epsilon, it's a very small number, as much small as we can do. That implies that date has to be equal to. Otherwise, no other way. We don't have any other way than this A equal to B. So that implies, so what we got here, L1 is equal to L2. What we get? L1 is equal to L. So this type of small things are there. I mean, so I have a sequence, I can have at most one limit, like that. So I'll not do much theory, but yeah, this was one of the thing we you wanted to say. Okay, well, let's unbounded sequence. It will be n square. Let's say n square xn equal to n square. Unbounded sequence. So boundedness is the necessary condition for sequence to convergent. So if it's unbounded, then it cannot be convergent. Okay, that's one thing. Yeah, and you have a sequence, then you add, that will be also sequence, and then if they are convergent, both are convergent, then this thing will also converge. The addition also will converge. So one of the important thing I will say today, another important is how do you show that limit of r to the power n, r is a real number of course, equal to 0 if modulus of r is less than 1. Sorry for the interruption. Now everything okay. Okay, so how do we show this? I mean, what that's saying that's minus half to the power n, half to the 1 by 3 to the power n, whatever this type of smaller numbers that will converge to 0. This is not true when n is r is equal to 1, that will be limit will have, but it will converge to 1 when 2 to the power n, it diverges unbounded. So it will be not be convergent. You can do case by case. Okay. How? See. Now let me again write the question. So r is less than half 1, mod of r. R belongs to real numbers, and then limit of Rn is equal to 0. Proof limit of Rn equal to 0. Okay, case 1, r is equal to 0. R is a fixed number, n is varying. Then it's trivially true, right? Trivially true. what happens when case 2 r is not equal to 0, r is equal to, sorry, not r is equal to 1, mod r is less than 1, right? So what does that meaning? That means 1 over mod r will be greater than 1, right? That implies, and 1 over mod r we can write because r is not equal to 0, r equal to 0 because we have already done. So then what we can write, 1 by r is equal to, 1 can always write 1 plus some a, where a is greater than 0, right? Because a greater than 0 means 1 plus a is greater than 1 plus something means greater than 1, right? And now we take what is r to the power n minus 0, that mod is nothing but mod of r to the power n, right? And that is nothing but 1 by 1 plus a to the power n, right? And what you can also prove, 1 plus a to the power n is greater than n times a for all n belongs to natural. And a is also of course greater than 0, is given. So that implies r to the power n, so r to the power n minus 0, that mod will be less than, sorry, is equal to 1 over 1 plus a to the power n, which is less than 1 by n a then, right? And what you can say then, r to the power n minus 0 is less than epsilon when epsilon less than 1 by na, or na, sorry, when here, so 1 by na greater than epsilon. Yes, yeah, that is true, right? Because that will only implies r to the power n minus 0 less than 1 by na, right? And that implies n has to be greater than 1 over epsilon k, right? So now if you take the k as 1 over epsilon a plus 1, this is greatest positive integer, then what I can write, then r to the power n minus 0 less than epsilon for all n greater than equal to k, and that implies r to the power n tends to 0 as n tends to infinity when r is not equal to 0. So that's how one can prove that this limit of Rn is equal to 0 when R belongs to set of real numbers capital R, but the modulus value is less than 1. So we can do many more questions from this, but yeah, this sequence again will be discussed in the next tutorial session also, and that will be hopefully the last tutorial session. There I will take little more extra class, so that whatever we have done in this class, I mean the little less, that can be, we can adjust there. So you can do some homework. I can give some homework type of, like, which you can, we can try to show that limit a to the power 1 by n is equal to 1, where a is greater than 0 and any real number. And from this, by generalizing, what you can show that limit even for n to the power 1 by n will be equal to 1. These are not easy, just you have to use step by step thing and you have to do. Okay, then there are many more questions which you cannot do now because it needs some more tools, you know. So this monotonical increasing sequence, bounded sequence, supremum, infimum, let's say squeeze theorem, and all these things, so that we can do it easily. So better for us to first learn those things and then do this sequence. So yeah, you don't worry about today's class because it's a little lesser it seems, but I will do more things on the last class. Hope all of you will join, and so that we can like I can, so we can make it make the this tutorial session successful, and that's the end of that, will be the end of the this lecture. So yeah, you please come and we'll more discuss about sequences and sequences, limits, and sequences, which is much important to learn, and to this is this plays important role in mathematical analysis, real analysis, and analysis, you know, is central in mathematics, right? It's used in PD, some real world applications, PD which comes from real world applications and all. So yeah, whatever is much important. This is so we should learn sequence. Also, I think series is there, so I'll do all those things, and if needed, we can have also extra session. That I will see whether it's needed or not. But yeah, there are, I have many more questions, many more problems which we can do it here. Okay, the next time, the next class I will do. Meantime, if you have any questions, you can send me your mail, or you can put in the YouTube, or wherever you want. You feel free to ask questions. I'll try to solve them, and I'll get back to you. And you have this, I think, some mail. I think I saw some feedback, some such things are there, like not feedback exactly. That is something of question forum or something, right? So you can write there also, and I'll try to solve them. So I'll check if anything like anything you are asking. I can check. I'll check there also. So I think that's all, but many more questions left. Okay, let's say we'll in the next class. What will is thank you for written, some is written, but leave it. So what we'll do this type of thing. So you have the subsequence, you have increasing sequence, and all these things. We'll show, we'll see many other things to characterize sequence. You can, if it's a monotonic increasing sequence, you have and it's strictly mounted on increasing, is keep on going, so it will be bounded. Mounted sequence, if it's strictly increasing, and if it's bounded, then it has to be convergent. So that type of things, and many things will be there. So once we are done with some theory, it will be much better. So that's why I'm not doing many questions, right? So we can prove these two sequences. First number is 2, and then 1 plus 2, 2 over 1 plus 2 over 1 plus 2. Just keep on going, they converge to 1. It's interesting. Try to think at home. Okay, so with all these things, I stop today's class, although it was very less, but yeah, we'll do in the next class. Thank you for your attention. Hello. Hello, Advait. So today I was done somehow. I mean, so like no one was there, so I could just do the problem. So you check maybe, and if you are not getting, you check the video. Once you check the video, then you will understand what I do. Nothing much. And anywhere on the like wherever it's contact number, then you contact me. So for today I am done for this. We'll like the sequence I did not do much because like we need some more tools to do some more interesting questions. So you need some monotonical increasing sequence, supremum, infimum of the sequence, subsequences, many more things which will come, and it will make things much harder and much interesting, which are also needed. It's important, right? So sequence and series I'll do in the next class. If needed, we'll do the extra class also. So what I would say is go through this video once, and hopefully you will understand. It's not difficult. You have any other doubt? Any specific doubt? Hello?
Hello,
Hello.
am I audible?
Yeah, now you're audible.
Yes.
Did you listen what I said? Like, did you hear?
No, I couldn't hear.
No, what I said is like I'm done with today's class because no one was there to listen. So you have to go through the video so once,
Yes,
and hopefully everything will be okay. Mostly, I mean, if you have some mistake I have done that you can take. Otherwise, also yeah, you go through once. It will be much easier today's thing. With
yes,
sequence and the latter parts where sequence done with subsequence and in monotonically increasing decreasing sequences and squeeze lemma and all these things, many things will come into the picture and it will make things much harder and interesting. So that's what I said. So we'll do like the next class. More thing we'll be doing, and whatever easy things were there like numerical integration I did it in the few like first 30 minutes, and then 30 minutes I started with the sequence, which yeah, we don't have much more things to do. You have to do the calculation and you get the things. I gave some idea how to compute things,
yes,
and I think that will be okay. You check once video, and we'll meet on the next so, in this Saturday only. If we
yes.
have,
But can I ask some other doubt?
I mean, how the doubt means,
Can I ask some other doubt, like other subject?
not not from this subject, right?
Uh, yes, not from sequences.
Sequences.
Not from sequences.
I mean, not from this calculus of one variable, right?
Yes,
Not from calculus of one variable, right?
yes.
Yes or no? I mean, it's a okay. Some algebra or something you're telling?
No, no, no. Analysis.
Not this course, but analysis, right? No, if you say
Yes.
then I will stop recording. That's all.
Okay, okay.
No, I will stop recording, then I can just discuss. That is not a problem.
Yes.
So it's not calculus of one variable, right?
No,
Okay,
it's not.
okay. Yeah, yeah. I'll just stop